Hi there. In this video tutorial, I'll show you how to use input-output redirection in Bash shell. Please note that this is a very important concept. In certain cases, we may want to capture output or results that we get from our commands or scripts or programs or jobs that we set up, so that we can later on analyze those results or those logs if anything is not looking good or any error occurred. So let's have a look at these three concepts of std in, std out and std error in today's session. Input output redirection. File descriptor number 0 is associated with std in or standard input. We use less than symbol to redirect std in or standard input. So what is that? Actually, these three are data streams: standard input and standard output and standard error. So standard input is usually or by default our keyboard. For example, let's see an example of it first. We have seen this read command several times. Let's use it to present a prompt. As you know, we need a variable to store the value that we will enter. Let's name it line. So we see now our program is waiting for an input. So this is std in that we need to provide, and we are going to use our keyboard to provide that input. So I'm going to enter this text. And as we know, we can print the value stored in a variable using the echo command. Let's do that now. This is standard output. See, file descriptor number 1 is associated with standard output. If you want to redirect it, we will use this greater than symbol. We will use the same greater than symbol when we are redirecting standard error messages. And file descriptor number 2 is associated with standard error or standard error messages. Let's have some more examples. I hit this command tat and we see the output on our screen or console. So in this case, our console or screen is the standard output device or the destination. Let's type this ls command, and I'm giving it a file name that does not exist in my current directory, and we see this error message right here. So our error message is also being shown on our screen or console. So we can see our standard output message, which is not an error. We can see the result from a command, which is again a standard output message or not an error message. And here we see an error message, so we call it standard error. So both standard error messages and standard output messages we can see on our screen or console. So we can say that by default they are being redirected to our console or screen. So we can change this default behavior of our system or shell program. We can ask our shell program to redirect these two types of messages to different destinations or locations. For example, log files. Let's have a look at this example. I'm typing this det command and providing it a file name that we will capture the output in. So let's name it stdout.log. As I have told you that we would use the greater than symbol to redirect the standard output. And please note that the file descriptor number 1 is presumed while 2 is not presumed. So when we are referring to file descriptor number 2 or standard error, we have to specify the digit 2 or the number 2 to mean file descriptor number 2, because in both these cases we are using greater than symbol. So we can explicitly type in the digit 1 or file descriptor 1 here, but it's not required, as I have told you. Let's keep it there for this exercise and let's hit the enter key and see what happens now. So we don't see any output on the screen or console, so we must have got this file now. Yes, it is there. Let's see the contents of this file, and we see the output from the det command is present in this log file. If we did not specify this file name here, the result would go to our screen. Let's take another example. This command is likely to generate an error message. Yes, we have seen it before as well. So let's use the file descriptor number 2 and the greater than symbol to redirect the standard error messages to a file. So let's call it stderr.log. So the result is not shown this time on our screen. We must have got this file. Yes, it's there. Let's print out its contents and we can see the output or the standard error message from the ls command has now been redirected to our log file stderr.log as we specified here. So this is how we can redirect standard error messages and standard output messages to different files. We can use one single file as well. I'll show you some more examples of this interesting concept. So we just saw these two examples. Okay, so what if we want to capture standard error messages and standard output messages together in one single go? So there are different mechanisms used. Let's run both the commands together to see how this thing works. As we know, this det command would produce a positive result, that is, it would not throw any error message, and this command ls would throw errors. We can use a pair of parentheses to run multiple commands as one single unit or as a group, and we can use a semicolon to separate each command. So now let's run this set of commands and redirect the output to our file. Let's name it all.log. As I've told you that 1 or the file descriptor number 1 is presumed, which means standard output only. So what just happened? The output from the det command has been suppressed while the output from the ls command has been shown. So what is in here now? The log file all.log has got only the output from the det command because only file descriptor number 1 or std out is presumed. So standard error message is still being directed to our console or screen. So okay, let's put 2 in there and see what happens now. Okay, so we see the standard output message on our screen but not the error message. So what is going on here? We see the error message has been sent to our log file. So in both ways we are not able to capture both sorts of messages in our log file. So to overcome this problem, we can use the ampersand symbol here. Please note that this method is supported in newer versions of bash, and I am using bash 4.1.2, so this will work in my case. So if it doesn't work in your case, you may need to upgrade your bash, or I'll show you some other ways to do it. So no worries. Okay, let's run this command line. So we don't see anything on the screen this time. So what we got in the log file? So we have the standard output from the det command, we have the standard error message from the ls command. Now both sorts of messages have been logged to our log file. Do you notice that every time we are running our commands or every time we are writing to our log files, the log files are getting overwritten? So we can use double greater than signs to change this behavior so that our log files or our text files will be appended to. Let's rerun the same statement and we are going to append this time. So let's see. So you see the old logs are there and the new logs have been added to the file at the end. So just in case if this method, this use of ampersand doesn't work in your case, we can have different mechanisms. So I'll show you some examples. So we can use standard output, redirect it this way, and then standard error message, redirect it this way, and let me just clear the screen. So we have, as we know that we don't have to put the digit 1 here, it's presumed, but we need to specify the digit 2 to mean file descriptor number 2 to redirect standard error messages. Let's see what happens. So we don't see anything on our screen, but the messages have been logged to our log file instead. So our log file is growing now, as you can see. So some people prefer to redirect the error messages like this. What this piece of code translates to is first let's look here that redirect is standard output to this log file, and whatever is going to the standard error data stream, redirect it to the standard output. So what essentially happens here, that we already have the standard output redirected to our log file, so error messages will be redirected to standard output, and standard output in turn will be redirected to our log file. So this is a bit better approach, because the other method I just showed you may not work if you are using an older version of bash or maybe some other shell if you are using. So let's see if it works in our case. So it works, as you can see. Let's verify the timestamp. So we got both the results logged to our log file. You would use this method in cron tab. I have not shown you how to use cron tab. In my upcoming video tutorials I'll show you how to use cron tab. So let's not worry about that as of now. So we have seen these methods, and okay, now let's see how we can redirect standard input. I think I have already written a script and which we can use to save our time. stdin.sh. Okay, as we know that we can use this read command to get input from user via keyboard. So we can use while to read in multiple lines from a file. So this time we are not going to type in anything. The input will come from a file we have specified here. This file should exist and should have some contents, so that a read command can read in from that file. So we have this statement here, read one line of input from this file, all.log specified here, and as you can see less than symbol is present here because we don't use greater than symbol to redirect std in. We use greater than symbol to redirect only standard output and standard error messages. We use the less than symbol to redirect standard input. So within my do and done block, I have this simple echo command, and we are printing the line number also. We can just leave it, but I have purposefully included it here just for some fun, let's say. So line number will be printed out, then a tab will be inserted, and the actual line of input that we get from this file in each iteration of the while loop will be printed out here. And here we are performing some basic calculation. So you see some more stuff going on in here. So we have these double pairs of parentheses. Inside these parentheses we have the variable here and the symbol plus typed twice. So what it means is whatever value is stored in this variable currently, just add one more to it, increment it by 1. So if it is currently looking lnum equal to 1, then here it will become lnum equal to 2. So there are different approaches. We can also say like plus equal 1. So let's use this method here, and after the done we have the std in coming from this file, so we don't have to type in anything. Let's save the file and quit. Let's make sure that we have this log file all.log present and we have some data in it. Okay, we have some lines here. We can see with the -n option to get command that we have 8 lines present in our text file all.log. So let's run the script and okay, so we got 8 lines of input and output. Let's have the script opened here. So you see that our log file or text file has been read in. With the help of the while loop, we are reading every line, and read command is actually doing that reading job and storing the lines in this variable called line. So in each iteration it's reading one line of input here, and it's getting stored in this variable when this command gets executed, and we are printing out the result here, and we are incrementing the line number and also printing it out. So that's it. Of course there are many more file descriptors available other than 0, 1 and 2, and there are many other mechanisms and or methods that we can use: std in, std out and std error data streams, and we will see their examples and some more complex scripts as we progress. Thank you very much.